Chapter 15, Number 18. A circular wine barrel 75 centimeters in diameter will burst if the net upward force exerted on the top of the barrel is 643 newtons, or I guess more. A tube 1 centimeter in diameter extends into the barrel through a hole in the top as indicated in the figure, which I'll draw in a sec. Initially, the barrel is filled to the top and the tube is empty above that level. What weight of water must be poured into the tube in order to burst the barrel? Our basic approach is going to be to try and find the pressure in the barrel that would correspond to it breaking. So we're going to take this force and see what pressure it would need, what pressure would exert that force on the top of the barrel, and then we'll figure out what height of water will produce that pressure. So we need to sort of think, first of all, that our pressure, P crit, or critical pressure, is going to be the critical force over the area of the barrel. So we're going to say it's 643 newtons over, it's a circular wine barrel, and we have a diameter. So it's going to be something like an area is pi r squared, and r is going to be 1/2 of the 75 centimeters, but I'll want to convert the 75 centimeters into meters. So there's 1 meter per 100 centimeters, all squared. (728 pascals). Now we're going to fill this tube with water. The whole thing is filled with water. I'm going to put some more water in it of a height h, and we know that the pressure that we gain will be rho gh, and so I can figure out the height as being the pressure critical that I want over rho g, and so that's going to be 728 pascals over the, we'll assume this is fresh water, so 1,000 kilograms per meter cubed times 9.81 meters per second square, giving us an answer of 0.0742 meters, or about 7 centimeters, which seems not unreasonable. And then we're going to turn that into the mass, and we're going to do that in the following way. We're going to say, oh, well, we have that the mass is going to be the rho of water times the volume, and in this case the volume itself is going to be pi r of the tube squared times h, because it's basically a cylinder of water, and so we'll get 1,000 kilograms per meter cubed times pi times half a centimeter in radius, but then we need to have that in terms of meters as well. So 1 meter per 100 centimeters times the height, which we just said was 0.0742 meters, and throwing all that together, we get 0.0058283 kilograms. I guess they asked for the weight, so I'd multiply that by g, and we would get that the weight that we want, Fg, is going to be about half a newton, 0.057 newtons, and that small amount will cause the thing to break.